Welcome to Lecture 11 of our Beginner Machine Learning course, and today I have a special treat. We are going to delve into a topic we have hardly touched on. We will explore the fascinating field of natural language processing, commonly referred to as NLP. As we dive into this topic, we will cover what NLP is, its applications, and some fundamental techniques used in the field. Let's go. So what is NLP? Natural language processing is a subfield of artificial intelligence that focuses on the interaction between computers and humans through natural language. Your mind is already blown, right? The goal of NLP is to enable machines to understand, interpret, and generate human language in a way that is both meaningful and useful. I mean, we are doing artificial intelligence, right? So very cool. This involves a combination of linguistics, computer science, and machine learning. Now, what are the applications of NLP? I mean, besides everything. NLP has a wide array of applications that impact our daily lives and various industries. Here are some key applications. How about chatbots and virtual assistants, tools like Siri, Google Assistant, and Alexa? Use NLP to understand user queries and provide relevant responses. They can perform tasks such as setting reminders, answering questions, and controlling smart home devices. And how about doing a little bit of sentiment analysis? Businesses utilize sentiment analysis to gauge public opinion about their products or services. By analyzing customer reviews, social media posts, and feedback, companies can understand how their audience feels and make informed decisions. We have machine translation services like Google Translate leverage NLP to convert text from one language to another. This application helps break down language barriers and facilitates communication across different cultures. There is text summarization. NLP algorithms can automatically summarize long articles or documents, extracting the most important information and presenting it in a concise format. This is particularly useful for busy professionals who need to stay informed without reading lengthy texts. So there is spam detection. Email providers use NLP techniques to filter out spam messages. By analyzing the content and context of emails, these systems can identify and block unwanted messages, improving user experience. And finally, information retrieval. Search engines like Google use NLP to improve the relevance of search results. By understanding the intent behind user queries, search engines can provide more accurate and useful results, and so much more. These applications demonstrate the versatility and significance of NLP in our daily lives and in various business operations. As we continue our exploration of NLP, we will focus on some fundamental text processing techniques that form the backbone of many NLP tasks. So what are some basic text processing techniques? In this section, we will discuss two essential text processing techniques, tokenization and stemming. These techniques are foundational for any NLP task and help prepare text data for further analysis. Let's start with tokenization. Tokenization is the process of breaking down a text into smaller units called tokens. These tokens can be words, phrases, or even sentences. Tokenization is crucial because it allows us to analyze the structure of the text and perform various NLP tasks. For example, consider the sentence, "Natural language processing is fascinating." After tokenization, we would have the following tokens. Token 1, natural. Token 2, language. Token 3, processing. Token 4 is, and token 5, fascinating. So tokenization can be performed at different levels. First, word tokenization. This involves splitting text into individual words. It is the most common form of tokenization and is useful for tasks like text classification and sentiment analysis. Second, sentence tokenization. This involves splitting text into sentences. This is particularly useful for tasks that require understanding the context of sentences, such as summarization. So, understand that tokenization can be performed using various libraries in Python, such as NLTK, which stands for Natural Language Toolkit, and another called Spacey but spelled SPACAPCY. These libraries provide built-in functions to easily tokenize text. Oh, we do like easy. That is tokenization. There is also stemming. Stemming is the process of reducing words to their base or root form. The idea behind stemming is to treat different forms of a word as the same, which can help improve the performance of NLP models. For example, the words running, runner, and ran can all be reduced to the root word run. Stemming algorithms, such as the Porter stemmer, work by removing suffixes from words. For instance, running is stemmed to run. Happiness is stemmed to happy, but spelled with an I. Better is, well, better. It is already at its root form, right? Now, while stemming can be effective, it's important to note that it may not always produce valid words. For example, stemming happiness to happy with an I may not be meaningful in all contexts. After all, how often do they mean one of these? Yes. Happy with an I is the English spelling of a Japanese shirt with loose sleeves. So stemming might have a couple of hiccups, but it can still be useful for tasks like information retrieval, where the goal is to match similar terms. In practice, stemming can be implemented using libraries like NLTK and Spacey, which provide easy-to-use functions for stemming words in a text. Now that we have covered some basic text processing techniques, let's explore two important applications of NLP: sentiment analysis and text classification. So, sentiment analysis. Sound like somebody overthinking their emotions, right? Well, it's not, I promise. Sentiment analysis is the process of determining the emotional tone behind a body of text. Well, maybe it is someone diving into emotions, but emotions of a body of text. Wild, right? It is commonly used to analyze customer feedback, social media posts, and product reviews to understand how people feel about a particular topic or brand. Sentiment analysis can be categorized into three main types. One is polarity classification. This involves classifying text as positive, negative, or neutral. For example, a review stating, "I love this product," would be classified as positive, while "I hate this product" would be classified as negative. I suppose neutral would be something like, "What was the product again? I forgot." So, two is emotion detection. This goes beyond polarity classification by identifying specific emotions expressed in the text, such as joy, anger, sadness, or fear. This can provide deeper insights into customer sentiments. Crazy, right? Well, my friend, you are getting into some crazy cool stuff here. And three, aspect-based sentiment analysis. This involves analyzing sentiments related to specific aspects of a product or service. For example, in a restaurant review, one might express positive sentiment about the food, but negative sentiment about the service. So how do you perform this sentiment analysis? How do you get all touchy-feely with a luscious body? Of text, you silly person. We are talking about text here. There are various techniques, including lexicon-based approaches. These methods use predefined lists of words associated with positive or negative sentiments. The overall sentiment of a text is determined by aggregating the sentiments of individual words. Also, machine learning approaches. These methods involve training machine learning models on labeled datasets to classify text based on sentiment. Common algorithms include logistic regression, support vector machines, and deep learning models. So that is sentiment analysis. Next, consider text classification. Text classification is the process of categorizing text into predefined classes or categories. This is obviously a fundamental task in NLP and has numerous applications, including spam detection, topic categorization, and intent recognition. So, text classification can be approached in several ways. How about rule-based classification? This involves creating a set of rules to classify text based on specific keywords or patterns. While this approach can be effective for simple tasks, it may not scale well for more complex datasets. And what about machine learning classification? This approach involves training machine learning models on labeled datasets. Common algorithms used for text classification include naive Bayes, decision trees, and support vector machines. These models learn to identify patterns in the text and make predictions based on new unseen data. And finally, how about deep learning classification? With the rise of deep learning, neural networks have become popular for text classification tasks. Models like recurrent neural networks, RNNs, and transformers such as BERT have shown remarkable performance in various NLP tasks, including text classification. To implement text classification, we typically follow these steps. Data collection. Gather a labeled dataset containing text samples and their corresponding categories. Text pre-processing. Apply techniques like tokenization and stemming to prepare the text for analysis. Feature extraction. Convert the text into numerical representations that can be fed into machine learning models. Common techniques include bag of words, TF-IDF, and word embeddings. Model training. Train the chosen classification model on the pre-processed data. Evaluation. Assess the model's performance using metrics like accuracy, precision, recall, and F1 score. And finally, 6. Deployment. Once the model is trained and evaluated, it can be deployed to classify new unseen text data. In conclusion, natural language processing is a powerful field that enables machines to understand and interact with human language. Today, we explored the basics of NLP, its applications, and fundamental text processing techniques like tokenization and stemming. We also discussed sentiment analysis and text classification, two important applications of NLP that have significant implications in various industries. As you continue your journey in machine learning, I encourage you to explore NLP further and experiment with different techniques and applications. Artificial intelligence, machine learning's mummy, is so cool. Just look at all the things it can do. Model, input, train, output, evaluate. It's all rather simple, right? We repeat a lot of stuff. How many times did we talk deep learning and dimensionality reduction? You have learned a ton. This is the next to last lecture in beginner machine learning. Take your notes, read them again, and sit amazed by your not-so-artificial intelligence. Till next lecture, like and subscribe for the sake of Tech Skill Hub and by golly gosh for you. This is Ethan signing off.